Hello, now we will talk about the machine learning life cycle, which I'm sure all of you must already know a little bit at least about because you all are data scientists or studying data scientists, right? And and the process is pretty similar. Like, it starts by preparing data. And then once you have your data prepared, you set up your model training pipeline, you train the model, you track your hyperparameters, you send it for visualization and evaluations. And once you have done a bunch of these steps, then you would want to monitor this model and continue on improving the efficiency, if that is the metric that you are looking at. But otherwise, continue on improving the model in one way or the other to reach the ultimate business objective of deploying that model. So that's a very simplified view of the machine learning cycle. The more complex view is on this slide that is right in front of you, and you can see that there is just a lot of steps that happens, and it depends on a lot on what kind of data do you have, what kind of problem are you trying to solve, and is it easy to create data versus is it hard to create data. And a lot of people deploy various techniques for data creation. Some of that technique involve including human annotators to annotate the data explicitly. Some of those techniques involve creating synthetic data based on existing data that you have. But regardless of what that approach is, the key is that you need to have that good amount of data and work on it. Now, as most of you might have already experienced, if you're working with a model for a decent amount of time, there are a lot of iterations that you do on that same model, and there are a lot of parameters that you need to track. And these parameters could be your related to the input of the model, the parameter of the model itself, or specific metrics related to the output of the model. And tracking all these metrics and creating different version of model based on your improvements, deciding which model to serve, which model to pull off. A lot of these is really a complex task, and it involves a lot more than simple data science. And as data scientists, you do have to deal with them. But fortunately for you, you don't have to do everything by yourself. And there are a lot of production grade tools that are available to help you with all these activities. So three tools that we will discuss briefly here. The first one is MLflow and DVC. So MLflow is I think one of the most popular production grade machine learning model development and life cycle management tools. So what it does is it has these four different APIs or verticals, right? Or components actually, not verticals. So MLflow has these four components that includes tracking, projects, models, and registry, right? So you can actually track each of your model. You can package your models in a project, and then the whole model itself you can deploy using MLflow. So you don't need a separate infrastructure to serve your models. And then of course there's a model registry that stores, annotates, and helps you discover what other models are available. So if you are a large team of data scientists, you are working on many machine learning algorithms, or even if everybody is working on the same objective but different algorithms, this is a great tool for you. You should definitely use it. Even if you are a single developer, this tool will make sure that all your models are versioned appropriately and you have everything consolidated in one place. The other very good tool for the same purpose is DVC, which is on the bottom right corner of the screen. And if you compare DVC with MLflow, you will see that a lot of features are very similar. They both are trying to cater to the same set of problems in slightly different ways. And again, for an individual or even for a team use case, MLflow or DVC, any of them would work really good. Kubeflow is a little different from MLflow and DVC, both in the sense that Kubeflow is designed with a specific deployment goal in mind, and this deployment goal is a Kubernetes based deployment. So Kubernetes is it's an orchestration platform. It helps. It was developed at Google, and it has helped Google and many other teams scale their infrastructure seamlessly, and it ensures that your infrastructure is always available, and you can do a lot more as to in terms of deployment, in terms of monitoring of your infrastructure. So Kubernetes itself is a huge and very powerful ecosystem, and the engineers at Google were working on how do they integrate TensorFlow with Kubernetes, and somewhere along those lines and on those discussions, Kubeflow was born. So if you have a Kubernetes based deployment ecosystem, then for you to serve machine learning models and continue on the whole life cycle, it becomes very seamless with Kubeflow. Some of the features in terms of model versioning, model tracking work a little better in MLflow, but again, like, it really depends on your use case. For some teams, Kubeflow might work really great out of the box. So the key takeaway here is that machine learning models have their own life cycle, and these life cycles can be really long life cycles, and sometimes during a life cycle you might not even be actively working on that model anymore, right? So it becomes very important to have a set of professional tools that help you organize your ML projects, your ML models, and you have a very solid reports as to why you are choosing, let's say, model A versus model B, and a whole history of how you went from, let's say, model A to model F, and what all things happened during those phases. So the use of these tools are really recommended, and that's all. Thank you.